Good morning. My name is Greg Alone. I'm one of the engineers at Xojo. This morning I want to talk to you about automation in the IDE, how to build your projects automatically and use scripting and that kind of thing. This is more of a mechanics session as opposed to like how to write the scripts. You can learn about IDE scripting in the documentation PDF file. There's a whole section on IDE scripting and what parts of the language you can use and the things we've added to make it easy to build. But I want to talk to you about the different ways because there's some confusion in the community about why you would use different types of scripting. Now, if you're like me, most of you would much rather be doing anything else other than doing a build. Builds can take a long time depending on your product. Ours takes a really long time. And build processes typically look something like this. You know, you're going to build a project, you might have to copy some dependencies, and this is assuming you're going to do it all manually, right? Verify the build, run some unit tests, and you'd cross them off as you're doing it. Might go get a cup of coffee, might go get breakfast, depending on how some of these processes go. And while repetition is a great thing, we as humans very often will forget a step, you know, or you get tired or busy or you fall behind. And what happens is we tend to skip the really important stuff because it's really time consuming. Running unit tests, verifying that the build is good. So Xojo has 3 different ways to help you automate your build process. We have build steps. These are things that are actually built right into the project, and you can copy files and ask questions and that kind of thing. There are IDE scripts, and these actually live either in a scripts folder next to the IDE or next to the project. So they can still be project specific, but they can do more complicated things. And then there's the IDE Communicator, and this one there's a lot of confusion surrounding how this works and stuff, and I'll do some examples of how that works later. So build steps are target specific. They're Mac, Windows, Linux. They could be for web, that kind of thing. On a mobile project, we only have iOS right now, so they would be iOS. And when Android comes, you might have a build step just for Android. They can be set to run on a build, on a debug, both. And then in 2016 R1, we added neither. So you can actually turn build steps off without moving them into somewhere else in your project, it turned out to be really, really handy to be able to do. And then there are 3 different types. There's embedded scripts. So you would put one of these in your project and you type in a script and it would just run when you do a build. There are external scripts. These are scripts that actually live on your hard drive and get loaded when you run the project. And then copy file steps. And the reason for copy file steps is so that you don't have to call out to a shell and say, well, I need this file over here and this file over here and this file over here. These are very specifically for just copying things to a particular place in your build. Demo. All right, so. We're going to hope everything's going to work smoothly. Okay, so, whoops. Really? The one part we need the screen recording for, right? Let's see if it'll continue to go here. Okay. So, all right, heck with that. So this project actually has 2 different build scripts. I've got a script that's actually in the project, which is for asking a question about which database you want to connect to. We actually use this type of a script in our iOS app when building, because sometimes you need it to connect to a local database, sometimes you need to connect to a remote database because it's a little bit easier to diagnose the local connections. And we also have a copy file step. This doesn't actually do very much, but it's copying 3 PNG files into the parent folder where the app is. And there's a couple of places that you can automatically put things, and you can always put a subfolder up there. But I want to show you this script because what it does is it asks a question and it actually changes a constant in the project before it gets built. So like in this case, this label will be set to the value of that constant. So if I just run it, it asks me which database I want to connect to. Now I've got 3 buttons here. Cancel will just stop the build. It calls a command called cancel build and it dumps out of the build, which is kind of handy if you go, oops, I wasn't ready to do that. If I hit debug and it runs, you'll see it goes to, it's going to point to a server that would be on localhost. And I can do it live and it puts a different constant in there and loads it that way. Those are really handy. We use them for, like I said, the iOS app. I use it for developing feedback and a bunch of other things. Okay, back to Keynote. Too many buttons here. Okay. So now I want to talk about IDE scripts. These are the ones that live in a script folder next to the IDE or next to your project. They're typically for one-off tasks. So you might want to run it and it would do a couple of builds. They can be triggered by hotkeys. We added the ability to use, Control, Alt, Shift, 1, and I don't remember what it was, but we added it so that you can actually use hotkeys to run them. And you can also trigger multiple builds at once, which is kind of powerful because you could say, well, I have this script and I want it to build Windows, Mac, and Linux. So you don't have to, and one of the things about it is because it's a script, you could have it ask, well, should I build Mac? No, then don't bother. Should I build Windows? Yes, do that. So you have a lot of control over that. And you can have it, the thing that people ask us about is, well, why don't you have 32 and 64-bit flags on every build target, right? Because I want to be able to build 32 and 64 at the same time. You can do it with this because you can say build app 32-bit, build app 64-bit. It does it. So the magic shuffle again. Oh, I was going to open this project again. Okay, so I actually have a build script in the folder next to the thing called Xojo script. And if I run it, it just builds. It just built all 3 IDEs, or I'm sorry, all 3 of that project, right? And in the build app method that you call, I can open that and show it to you. I think I can anyway, or not. Is it control? So build app is a method, all right? 3 means 32-bit Windows. These are outlined in the manual or in the documentation for Xojo, what these values should be. This Boolean indicates whether or not you want the IDE to bring the built app to the foreground. Because if it came to the foreground every time, the IDE would keep switching back and forth in context and such. And you'll notice I'm doing a call. It returns a string that indicates where it just built. So if I change this one to print, it actually will show us a dialog of that's where it built it on my computer. So you can use that path to say, oh, well, I need to go do some zipping, or I need to go do something else with the project, or the built app. It's handy if you need to do on the Mac, like if you need to do a plist modification, because you have the actual path of the app file. Okay. It didn't come to the foreground. Okay. I'm screaming along here. We're going to have lots of time for questions. So the IDE Communicator, like I said earlier, is kind of misconstrued, and there have been a lot of people who have tried it and said, oh, this is too complicated, I don't want to do this. But when you start getting to a point where the IDE scripts, the stuff that you build into your project and the ones that you put next to your project just aren't enough. Like if you need to build using a builder that's out on the internet somewhere, you really need to switch over to using something like the IDE Communicator because you want to do it automatically. And the way this works is you have a console or a desktop app that there's a project in the examples folder that shows how to make the IPC connection and that kind of thing. I'm sorry, getting ahead of myself. It's an IPC socket. And it allows you for some on-the-fly script generation. So your console or desktop app could be making decisions about what it should be sending over to the IDE to do a build. Getting good at. Okay. So for example, this is kind of tricky because the IDE is going to call back into itself and do a build. But so for example, this little app, when I run it, I can tell it, well, I want to build Mac. And you saw in the background it did a build. I can tell it to do Mac and Linux. Oh, it's trying to close it, but yeah. Oh, nice. Try it again. I probably have a quit there at the end, so it probably killed it, but let's try this again. When I do these, I typically quit the communicator, or sorry, quit the IDE when I'm done, because you typically do a build, and then you really don't want the IDE in the background continuing to run, because you want a clean state the next time it runs, so it's very likely that I've got to quit there. So it's going to do a build, and then the IDE goes away, right? So you can go on and do whatever other scripts need to be done. Okay. See, I put a note there that says, and then the IDE quits. Okay, so let's talk a little bit more about IDE Communicator, because one of the things that's happened since the last XDC is that we've automated our builds. And there were a couple of people at the last XDC. Philippe was one of them. Black Bag was at the conference last year, and they made some comments about, well, you know, it would be really nice if it could do this. It would be really nice if it could do that. And we're like, yeah, we'll get to it, right? But we did it ourselves, and part of the reason we did it ourselves was because there were some concerns from the people that were using this technology that there were holes, that there were things that they couldn't do very easily. So as we went through the process, we actually started revamping how IDE communication is done. So sometime next year, we're hoping that we'll be able to release this to the people that are doing the more complicated stuff. So we now have two-way communication. This means that the IDE Communicator can send a message and get something back. So you can actually have this two-way communication with the IDE over a long period of time without having to close the socket. Because right now, you send it, you get an answer back only when the socket closes. And then you have to wait for it to reestablish and all of that kind of stuff. We're using JSON response strings. Request and response strings. So you put together a request, you send it over to the IDE, and you get a response back. And one of the most important parts is that we get load errors and we get compile errors now. So what happens is when you do a manual build, what you get this, down in the messages pane at the bottom, it says, well, there was a syntax error on line whatever. When you're running in this mode, you actually get a JSON string back that says there was a compile error and it was on this line and here's what the error was. So you can feed it back into your system and go warn the appropriate people that, hey, you screwed up our build. Okay, so I'm actually going to show you how that works. No, you're not going to open the intermediate. You're going to open that one. Now, what I've done is you'll notice that I've got this intentional error in here. Oops, that would help, wouldn't it? Is that better? There we go. So I've got this intentional error in here, but it only happens when it's not a debug build. So what I'm going to do is I'm going to run the app, and then it's going to try to compile itself, so you guys can see the error. So I'm going to connect. Now, what I'm going to do is I'm going to do it the old way first. So if I just do a regular setup, and I try to do a build, you'll notice in the background we got, well, the IDE stopped, and we'll talk about this in a minute, but if you're doing an automated build, what happens is the IDE just sort of stops, which means, you know, an hour later, someone notices that the build is hung or failed, and you go to the builder and you go, oh, geez, you know, how long has it been like that? So let's do it the other way. Whoops. Let's do it the other way now. I'm going to quit that so it starts fresh. Okay, so now if I do a build, you'll notice we did get the error, but we also got this JSON string down here that was sent back to the app. So it's got everything that would have gone to the messages screen now comes back as a JSON string. So you can send that back to your build system and notify people immediately. Yes, and the IDE isn't hung, so you can send a quit command and go along your, you know, continue your pipeline and send error messages out and that sort of thing.
Yesterday.
I went to Philippe yesterday and I said, you need to come to my session. Okay, let's get back in here. And this, okay. Okay, so now what I'd like to do is give you a brief case study of a transition between doing a build process completely manually to being completely automated, okay? And the case study is the Xojo IDE. As I mentioned last year when we got back from XDC, one of my goals was to start automating the IDE builds. We had a very practical reason for this. We were going to be introducing 64-bit in R3, and that meant that frameworks were going to have to be built twice, right? And with Raspberry Pi on top of that, we had yet another framework to build. The amount of time that it was going to take to actually build the IDE was going to go up significantly. So our build process looks something like this, okay? The build framework step was going to get a lot longer, and we've got all these other things that have to be done. These are about the approximate amount of times that they were taking before we added all of the extra framework stuff. That's 8.5 hours of someone sitting in front of a computer waiting for it to be done. Okay, now, obviously you can go do other things. Building frameworks is actually was already being done on build machines, but everything else was being done by hand. And that meant, you know, starting it, go get a cup of coffee, go do something else, maybe work on fixing a couple of bugs, come back, find out it's been done for 30 minutes. Oh, I just wasted 30 minutes of the build process. So like I said, last summer when we returned, we wanted to automate the build process. We've had several build engineers over the years. The most recent one was Stefan. And the problem that we had was, and it's not anybody's fault, but because Stefan was in France, we had a limited time window from 11 a.m. when we have our engineering meeting to a certain time in the afternoon where we could say, we want another build. Because if Stefan was going to be involved, he has to sleep sometime, right? So we could end up spending a lot of time. So let's see, what did I just miss here? Oh, and on top of all this, we now have our partners from Grape City. So we were going to start building Japanese IDEs on top of this, and they still had to be signed, and all of that work had to be done as well. So now, with the automated system, from beginning to end is 3.5 hours, and we can do it whenever we want. We can just say build and walk away. When we were doing this process, I was reading a book about automating processes and making sure that we were going down the right path. And one of the books starts out by saying, computers laugh at us when we do this. because they're really good at doing lists of things. If you tell them exactly what to do, they'll do it exactly the same way every single time, as long as all the outside variables are consistent. Whereas humans, we're not really good at this. I mean, if you're a little bit tired, or you've done it 3 times already today, or whatever, you tend to miss things. So it used to be that the time from when we decided that we wanted to do a build to when it would be available for review could be as much as 18 hours. Okay? This is the way it was before XDC last year. Actually, just after XDC last year. When we automated our build process, it now takes 2 hours for the actual build part of it to be done. Okay? And then we also get this nice extra thing, because now we're running unit tests every single time, and we build installers every single time now. And the process ends up being 2.5 to 5 times faster, depending on the day and all the pieces that have to be built. So let's talk about what this gets us, because some of you are going to be like, oh, that's a lot of work. Why would you want to do something like that? We're now doing nightly builds. You guys don't see all of them, but we get a build every day that there is a change made to the frameworks or to the IDE, we get a build. And that means a couple of things very important to you. We get faster turnaround on bugs, because you get if we introduce a bug, we can actually find out about it a lot faster into the process. We also get continuous regression testing. So in the frameworks that are still in C++ and Objective-C, we still have William and Joe still do that part of the engineering, and some of that stuff we don't catch until we used to not catch until a lot later in the process. This is the build board that we have. And I'm gonna walk over here for a minute, and just to give you an example, this pipeline here belongs to Norman and I. Every time we check something into the IDE, this one runs. And this one, all this one does is it builds an IDE on all 3 platforms. It doesn't give us anything back. It just tells us, when you just checked that thing in and you only checked it on the Mac, you broke Windows and Linux, right? These 3 are for actually building the nightly builds. So it'll build frameworks. I should stop touching that. It'll build the IDEs, and then it'll run the unit tests. Everything on the top line is beta builds. So once we branch for beta, because what we do is we run in the trunk of our Subversion system, and then when we get to a beta and we're going to start releasing it to you guys, we actually branch so we can continue working towards the next build in the next release. We turn that one on, and that one will build frameworks for that, do builds, run installers, and we're working on one for automatically releasing to the beta list as well. But you'll notice across the bottom, we also build Lingua, and we build the remote debugger stubs, and the iOS image maker. And what you can't see below this is that there's another 30 pipelines that are being run to build our internal ordering system and feedback and all of that stuff. Once we kind of got the hang of the system that we were using, it became a lot easier to just add more products. And you kind of don't want to do them anymore. You don't want to do them by hand, because it's like, oh man, it would be so nice that I just check it in and it tells me 15 minutes from now if it's done. We also use our iOS framework to make a client so that we can review this on the fly. So I can go in, I could be out somewhere, I've gone out to get lunch, and maybe Travis will call me and say, hey, the builder's stopped. And I can go in and I can look at it and go, really, right? And I can select it and I can say, run the build again. Like I said, lots of time for questions. Do we have any questions? Yes?
Is it possible now to have a different name for the build, for the application? Is it possible to change it?
The question.
If I have the same app and I want to have one with one name and another name.
The question was whether or not you could change the name of the app on a per build basis. Yeah. And the answer is you can do that from a build script. You can also do it from a constant. So you could make a constant in your project and put it, so it could be different for Mac, Windows, and Linux if you wanted to do it that way.
Right.
But if you needed to change it like change the name on a particular day, you could use an IDE script to call into the operating system, find out what the current date is, and then use that to rename the app. But you got to do that before the build step. Let me show you real quick, since we have the time. Yep, I will. Just 1 minute here. Okay, so you'd have to do it in a script. This build step is visible on every target. Let me see if I add one here. Right? So that build indicates the IDE is going to do the build right here. So anything that you need to do before the build, you put above it, and anything that you want to do after it, you put below it. iOS targets actually have another step. They have one called sign, which does the signing and making sure all that, making sure all that stuff is ready for deployment. And in that case, copy file steps needs to be before the sign because you need it to make sure that all the contents also get signed. Questions? Fred?
For IDE Communicator 2 that you're going to release next year, or whenever that is, are there any other big changes beyond the two-way communication with JSON strings?
The question was for the new version of the IDE Communicator, are there any other significant changes? And the answer at the moment is no. We found that adding just the ability to communicate back and forth was such a huge leap forward that it solved 90% of the questions that people had been asking about how to do it. For instance, one of the questions we keep getting asked is, when is there going to be a command line compiler? This almost negates the need for that because you no longer have to rely on the IDE just sort of freezing to know that it didn't work. Questions? Gino?
In your project, you can add folders. We have a folder that's called debug. For the release, we always remove that folder and set a constant to false. Is that also possible with build automation?
I think the question was that you wanted to be able to add and remove folders with build automation.
Yes.
Absolutely. Our build process is mostly written in bash. So you could, from a bash script, you could add folders and put things in there and put them where they need to be and use the IDE communicator to do the build.
So in code, you can just say this debug folder with all these modules in it?
Sure, absolutely, yeah. The IDE process, I don't know if I can actually show it to you. It depends on whether Wi-Fi is behaving this morning. Oh, and it would help if I browser. Oh, Chrome. No, I can't show it to you. Darn it. All right. If you want to see more about the build process, I can actually show you guys the scripts, the running of the scripts, but I can't do it from this environment because I don't have my passwords and such.
How do you automate your code signing and installer building? That's the slowest part for me.
The question was how do we automate code signing and installer building? And what we do in our pipeline is they're done from scripts. So code signing is done as a bash command. For the Mac is done as a bash command. And one of the nice things about the, let me see here. The tool that we're using, let me bring this back up. The tool that we're using is called go.cd. They're a relatively new company in the pipeline build automation process, but they're backed by a company called ThoughtWorks. Originally, this was a product they were selling, and when you read through their blogs, it looks like they decided they couldn't make money at that. So what they did was they open sourced this part, and now they sell service. right? So if you need help setting this up, they'll sell you that kind of service. So it turned out that it was easier for us to use Bash on individual machine, Bash on a Mac machine, and PowerShell on a Windows machine, and Bash on a Linux machine. So we do code signing in there, and then we use DMG Canvas for actually building the DMG file. I've had a lot of communications with the DMG Canvas folks over the last year. I actually remember talking to Philippe about it because you guys were using a third-party tool to burn text onto images, right?
Actually, we wrote that tool
Right.
so that we could have text on it.
Well, it turned out that I got tired of having to do that. And I contacted DMG Canvas and like, guys, you guys let us put text on them. I need the ability to change that text when I call the DMG Canvas command. And he goes, oh yeah, I can do that. And the next release, that was possible. So you can actually put your version number actually on the DMG and stuff now. That's really cool. But yeah, everything is being done in Bash. So.
Just in addition to what Gino was just asking, because I was experimenting with the build process at work, what I did is I wrote a small console application in Xojo, and I launched that one, and it does all sorts of tasks. So you can just compile your own Xojo program and start that one from the build automation. That works great. I upload the files automatically to our service and stuff.
Okay. Questions? Kim?
No, just two comments. One, you do a lot of this stuff, right, from post-build scripts using do shell scripts, and that's the command in Xojo script. And you can just go right to the shell and have to do, use ditto to compress it or zip to compress it, and then move files around, and then use curl to upload it. You should do all the right Xojo script. That's one comment. The other comment is, for those of you who don't know, I have an open source Xojo script editor out there. That's called XS Edit that will actually communicate with the IDE and run the script through the IDE and report back where the bugs are. It's a little nicer than doing it right in the IDE.
So the comment for the tape is, Kim has some cool stuff. Go see his website.
At least my GitHub.
Questions? Philippe?
So regarding the command line interface or tool that this almost negates, I have two questions. One is, it still needs a UI because you're launching the IDE, so you can't just SSH into a build machine and run a command line build.
True.
So that would be one reason, because the display manager is not initialized. The other one is, it would be great to have a different license for a command line only interface. Because right now you have to use a full Xojo license to build.
Right,
So,
you do.
and if you want to have lots of agents, because you've got lots of products to build, each one of them is essentially a part of your pro license or more pro licenses.
Right. Philippe's comment was that you needed to have a license of Xojo for every build machine. And yes, that's true for this type of build process. Questions? Nobody? Okay. Well, thank you for coming. And if you, like I said, if you want to see the build process, the more in detail and stuff, come and find me somewhere, and I can let you see some of the way the script works and such. Like I said, this is the build. This is like the screenshot I showed you earlier. This is our build process.
So you have a broken build on the installer?
Yeah, we do. Well, so the funny part about it is one of the things that I'm communicating with the Go folks about is that you need a way for a pipeline to succeed but not continue. Because in the case of the Linux installer, because the error was that the Linux installer didn't work, and the error was, we don't need one today. So I need a way to say, stop, but everything's okay. And that was the error there. And like I said, if I scroll through this, you can see we're building all kinds of stuff with this. But if I go in here, let's go into Release Builder. You get a summary of all the changes that were involved in this particular build. Because we pull from, I think, 9 different Subversion repositories and 1 from Git to do our builds. Green obviously means, yes, it worked. It went through all the way. You can see if I go to Dependencies. Hello, come on. Oh, I'm clicking too fast for the web. You can see that while the release builder worked, we had failures on all kinds of things downstream. But if I go in here, you can see the output of some of the... hello?
Greg?
Yeah.
Rain on your parade, but don't show the console logs because there's information that should not be public.
Oh, okay, then I won't do that.
Greg, can we see the console logs?
The lawyers just told me no. But we do have, like I said, we do unit testing, and we can get information about how long they took. So the red ones obviously are, like this one, for instance, I was talking about IDE Communicator 1.0. This is a failure, and the IDE just stopped. And an hour and 19 minutes later, we found out that something was wrong. Unfortunately, because of the way our pipeline is, it actually hangs. So it's not even like the builder gets hung, and we actually have to physically go in and say, stop. But you can see that it's fairly consistent in the amount of time that it takes. And you can get access, in the case of Go, you can actually call into the pipeline and find out if a build took longer than previous ones, which might be an indication that there really was something wrong, even though it thinks it finished properly. So we've been spending some time with the analytics and adding more and more to our build process to make Xojo faster and easier to build. So, any other questions? Okay. Well, everybody have a good day. I have another session this afternoon at 4 o'clock. We're going to talk a little bit about Retina. Philippe has a session about unit testing this afternoon. And there's another session, I can't remember who's doing it, about Xojo script. That's, I think, tomorrow. So if you're interested in learning about the scripting language. Sure.
In my session, we'll do a lot of live coding and scripting, and we'll actually install Jenkins and build the CI system and get the CI system going on the machine, on the screen. So you'll have all the tools you need to do that as well. I'm not using GoCD, but
right.
Basically you'll have all the tools you need to get started.
Jenkins is like the GoCD. I'm sorry, he was talking about in his session, he's going to show setting up a system like this. Jenkins is similar to the GoCD product. And we're going to shut it down.